Hi guys, good morning. I'm here in Southern California, Biola University, where my daughter's about to graduate up there on the stage there. All right. Wanted to real quickly give you a quick rundown of this problem that a lot of us had challenges on with this piecewise function. And then you're going to get an opportunity to do another problem to replace the score here. So quick rundown. I'm going to post a longer version of this on Canvas. So if you want more details, you can go see that video on Canvas. Here's the short version. Okay. We got a piecewise function. It's defined on these two parts differently. Okay, so we want the average rate of change. Start with your definition. Average rate of change, f of b minus f of a, or b minus a. Okay, write that down. Then ask yourself, what is b and a? Well, a is -3, b is 4. So plug that in. Take one step, okay? You're justifying here, all right? And you're keeping your head on straight. How do you find f of 4? Well, 4 is defined for the second one here. So plug in 4 there, and we're going to get -1. Plug in -3. All right, what's f of -3? Well, -3 is defined for here. So plug in -3. 9 minus -3 squared is 0. You get 0. Plug those back in, and we get -1 minus 0. We got 7 on the bottom. -1 minus, or -1 7. That's the idea. So that's average rate of change, AROC. Okay. All right. Now, all right. Here we have part 2. So part 2, we want to write an equation for the tangent line at x equals 3. Well, we look at the function. When x is 3, we're using the second definition here. All right. So second part there. So that's the cosine equation that I have written down here. So I got to find the derivative at x equals 3 because we need slope of the tangent line and we need a point for point slope form. So we take the derivative. That's going to be, this is -1. Derivative of this is going to be 3 pi over 2 sine pi over 2x. Little chain rule going on there. All right. Ignore this red line that I don't know where it came from. Okay, now we got to plug in 3. So we plug in 3 for x. And let's evaluate this. Well, this is sine of 3 pi over 2, which is -1. All right. And so this just cleans up to -1 plus 3 pi over 2. Leave it like that. You don't need to do anything with it. Now we need to find the point. So plug in 3 into this. F of 3 is -3. And 3 times cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. So this goes away and we're left with -3. So the point is 3, -3. We have a point. We have a slope. Let's plug it in. The point, y1 is -3. So it's minus -3, which is +3. The slope is that thing, put in parentheses. And x minus x1 is that. Okay. I know I'm going fast, but again, we'll put the longer version on Canvas if you want to watch that. All right. Next part. Here's our function I copied up here. Okay, we want to find average value. Okay, when you see average value right away, 1 over b minus a times the integral of f of x dx. It's an average. This adds up the function, and this divided by the width. Okay, so it's like the total number divided by how many there are. Start by that. Write it down. Super useful. Then plug in your b and your a, 4 and -3, 4 and -3, f of x. Okay, start there. Now, and then ask yourself, how do I integrate f of x? Well, it's in 2 parts. So we have to break it up because it's different over those 2 intervals. So we break it up into 2 integrals. One from -3 to 0 of the square root function. One from 0 to 4 of the cosine function there. Okay, that's from those bounds. And that 1/7 is outside the whole thing. Watch out for that. Now we got to integrate this. Well, how do we integrate this? Can we do U substitution? Nope. Trigonometry? Nope. Okay, or inverse trig. Then we got to think about the graph of this. All right, this is a weird case. You haven't seen this much. All right, so don't stress too much about it. But think about the graph of this. The graph of this. If we solve it here, square both sides and add the x squared, it's a circle. X squared plus y squared equals 9. Square root of 9 is 3. So it's a circle with a radius of 3. Really, it's a half circle because it's the positive. So the area of this is pi r squared cut in half. Pi times 3 squared, so that's 9/2 pi. So that's how we find that integral. Little special case there. Don't stress too much about that. How about the integral of this cosine? Now this we should be able to do. So even if you, by the way, you get a point for doing this, even if you can't do this. If you got stuck here, but you did this, you would get a point. Okay, so do what you can, and you'll likely get points on it. Okay, to integrate this, well, we got -x squared over 2 To integrate this part, you got to kind of do some U substitution. I kind of rewrote it like this to keep my head on straight. I need a U to be this. So I need a pi over 2 here. So I need to multiply by 2 over pi outside. So that's where this 3 over 2 over pi comes from. And the antiderivative of cosine is negative sign. So I'm sorry, positive sign of pi over 2x. Okay. So there we go. We got that. Okay. Now we're going to evaluate this. This is 1/7 times 9 pi over 2. And then plug in 4 here. You're going to get -8. Okay. Work it out. Okay. This gives you 16 over 2, which is -8. When you plug in 4 here, the sign of 2 pi, which is 0. This all goes away. That's -8. Plug in 0. This is 0. This is 0. Boom. Keep things straight. So this becomes 9/2 pi plus -8 or -8. Okay, leave it like that. You don't need to simplify anymore. You probably would get credit if you left it like this. Okay. All right. Last part here. All right. We want to now. This is we want to say that this has a maximum. All right. And there's a name for this, but if you don't state the name, you'd still get credits. Okay. So the name is extreme value theorem. We'll see. Okay. We got to find out if this is continuous. If it's broken, then it doesn't matter. So we got to find the limit of the first part as x goes to 0 from the negative from the left. That's this using the left. Well, as we go to 0, this becomes 3. From the right, we're using the cosine part. And so as x goes to 0 from the right, the positive there, plug in 0 to this, and we get 0 plus 3 times 1, which is 3. These are the same. So f of x is continuous on that interval. So we can say since it's continuous on this interval, it has an absolute maximum. All right. If you put by extreme value theorem, that's fantastic, but you probably get points with that. If you said it's continuous and you showed that it's continuous, that's how we show continuity, by the way. You got to show that we did up top here. Okay. And then we can say it's continuous, so it has maximum. Okay, great. We'll leave it at that. You guys are going to get a chance here to do another question together, and I'll put the points towards this. All right. Review, remember, bring things to mind, study, but get sleep on Sunday at 6:45. I'll have pancakes ready in my room and breakfast stuff. Come on over, cheer each other on, and then you need to be in the room by 7:30 to do your testing. Okay. All right. Thanks a lot. Great job. And we'll see you on Monday.